Okay, welcome back to one of the lecture videos for reactions of acids and bases. In this video, we'll be specifically looking at on the second table, and there's a second dot point in the right-hand side student intended learning box. It says, undertake stoichiometric calculations for reactions between acids and bases. So that's what you will need to be able to do after this video. Alright. Now in previous video, we looked at different types of neutralization reactions. In this video, we'll be looking at, well, what you can use that knowledge for. Now, in practical setup, we'll be using burette, we'll be using conical flask, and by putting something unknown, solutions with unknown concentration, into the conical flask at the bottom and putting burette through, you should be able to figure out the concentration of the unknown solution that you've got. It's extremely useful when you are working as a water quality scientist or a soil analyst, because say farmer wants to know how much lime they should put into the soil to cancel out the acidity that they have in the soil. They would want to know how much exactly they should put into soil. Too much would be waste of money, too less would not be effective to grow crops or whatever. So we'll talk about this thing called titration to start with. So titration, it is a volumetric analysis procedure to identify the concentration of a solution. Analyte is something you are analyzing, solution with unknown concentration. Whereas, just waiting for that to come out, titrants is a solution with known concentration. So you use titrant to analyze the analyte, and that's titration. Equivalence point is where the H3O plus, so if you had some acidity to it, and if you keep adding OH minuses, and if they become exactly the same number or more, then that's where you call equivalent point is. And if you are doing that in the lab, you might not be able to see how many molecules of say OH minus you're adding to. So you need to rely on indicator. Now indicator tells you about the place where the equivalence point occurs, and the point that you can observe is called the end point. And the point is where if you're using phenolphthalein, you will see very pale pink color. That's where acids and bases are almost matching in terms of number. All right, so let's look at titration and apply the stoichiometric knowledge to it. So if you're trying to find out the concentration of HCl solution by neutralizing it with NaOH solution with known concentration. Now think about which is analyte and which is titrant again. Reaction wise, there's an equation there. HCl plus NaOH that produces NaCl and H2O. So fairly straightforward acid plus metal hydroxide equation. And that's a setup. So you have a conical flask at the bottom. Sorry, we'll start with top, burette. That's where NaOH solution will go, because you know exactly what the concentration of that is. And at the bottom, in the conical flask, you add the acid solution, which is something that you don't know the concentration of, but you know exactly how much you have put into. All right, so information-wise, what do we know? In NaOH solution, you know the concentration. In this case, let's say that was 0.500 moles per liter. Volume you used to reach to the end point of the reaction was 15.55 mils. you can read up to 2 decimal points on the burette. Molar mass may be useful, may not be useful, depending on what you're asked to find out. The concentration of acid there, HCl, is not something that you know. Volume, though, you know exactly how much you have added into the conical flask to start with, so that was 20 ml. You can also tell the molar mass by looking at the periodic table. By looking at the equation, you can tell the stoichiometric ratio between HCl and NaOH was 1:1, which would be really useful and handy for you to know. Alright, so let's find out what the concentration of HCl was by just knowing all these. So, solution. Now, before you move on to anywhere, you need to find out how many moles of hydroxide you have added into acid. So, N equals to C times by V, volume. If you plug in the number, so 0.55 was the concentration, moles per liter, and volume, we had 15.55 milliliters. You need to divide that by 1,000 to make it into liters. So you can find that number of moles is 7.775 times by 10 to the power of -3 moles. All right. Since we know the mole ratio of NaOH to HCl is 1:1 from the equation, that means the number of HCl would also equal to 7.775 times by 10 to the power of 3. Same number. By knowing that, now you can find out concentration of NaOH by dividing the number of moles of NaOH by the volume that was present or used in the conical flask. So it should look like that. 7.775 times by 10 to the power of -3 divided by 20.00. So that's what was added. Divide by 1,000, again to make mils into liter. If you put that into calculator properly, you should get 0.38875. Now that can be an answer, but even better if you used the significant figure. Now by referring to the question, you would see 3 significant figures as the smallest significant figures, because others were 4 significant figures. For chemistry, you pick the smallest one. In this case, 3 significant figures. So on the 4th significant figures, you have to round that up or down, or cut down. Yeah. In this case, you get round about 0.389 moles per liter as the final concentration. Now, it looks like a lot of steps are involved, but if you can picture how titration can be done in a practical sense, and if you can picture that while you are calculating all that and backtrack what the concentration was, that makes it so much easier. Now we'll have a lot of practice with it as well. So yeah, as long as you can write this down, the example is done.